Hello everyone, it's Benny, and today we're going to be continuing work on the 2D role-playing game that we started in the first video. So just as a quick recap, so far we set up the game engine, we have created the player, which is actually pretty close to finished, and we also created items. So, all in all, we've done a fair bit of work in the past couple of videos. But we still have a few more things to do, and in this video what we're going to be doing is, first off, we're going to be cleaning up the item system, because the way we implemented items so far, it works, but it's definitely not the greatest way to do it. So we're going to be cleaning up that system a little bit. And other than that, what we're going to be doing is we're going to be setting up the inventory for the player, and if that's all finished, then, well, we'll see how much time we have. So, to go ahead and get started, let's just go ahead and clean up the item system, because I think that's a fair place to start. So, first off, if I look in our cube class, this is our basic item. We have our constructor, and our pickup method, and our update method. The problem with this is these are all pretty generic methods. These methods are going to be done by just about every single item. So, what I'm going to be doing is I'm going to be just cutting these, for example, all the code in the pickup method, and moving it over into the item class, because this is pretty much all we're going to be doing for every single item. And if we do anything differently, then we can just override them, because that's the beauty of object-oriented programming. So I'm going to cut out everything in the pickup method and move it over into the item class, like you just saw. I'm going to be cutting out the player variable and moving it over as well. Now, I will need to change this to protected and import the player class, but I'll need to change this to protected here. And the reason for that is that, well, I'm going to need to inherit the player object. So, I'll need to inherit this variable, so I'm just going to change it to protected. And the update method, I can just cut this entire thing and move it over, because it's overriding. So, I'll need to import physics from the game engine. And really, that should be just about everything. Other than I can delete this method now, since I'm not using it. Oh, and I almost forgot. I need to add a constructor to the item class, because if I look here, you'll notice that I have my player assigned here, but here I don't assign the player anywhere, so I need a constructor. So I'm going to create just public item. It can be a very basic constructor. I'll assign that player to that, and here I'll just copy all these parameters and take them in here. So these will be my basic. Actually, I'm just going to need to take in the player, because I'm not going to do anything else. So this will be my base constructor, and now all I need to do is change the cube around a bit. And really the only thing I need to do here is I need to call the item constructor. So the way I do this, I call super, and I pass in the player. And this is now pretty much the code we'll need for every item. And it's a lot simpler and cleaner than what we would have had to do if we hadn't made all these basic changes. So there, that's the first thing we're going to do. Now, the next thing I want to clean up is the remove method. Because right now we have this remove system, and it's really simple. It's just a Boolean system. And it works, and I don't really want to change how it works, really. What I want to change is I want to make it more generic. Because right now, all we can do with this system is we can just remove it. I want to set it up so we can do, theoretically, anything with this. So, I'm going to change this Boolean remove into a flags system. And this flags system will just be an array of booleans, which we'll be able to use to talk to our game. And we'll be able to tell it pretty much anything we choose from a series of booleans. So in this case we'll only have one, but it'll be much easier to expand than what we have right now. That's the whole point of it. So, I'm going to create a boolean called flags, not glargs, can't type. Can create a boolean called flags, and I'll just put the array here because I prefer it that way. And I'll go ahead and initialize it here because we don't have any other good places to initialize it. So it'll be a new boolean array, and I'm just going to set it to size 1 because right now we only need 1 flags, whether or not we're going to remove. And for the remove method, we're just going to set flags sub 0 to true, and here we'll return flags sub 0. And that will be our remove system. And it works almost exactly the same, but now we have a much easier way of adding on flags. We just change this, to 2, and now we have another flag that we can use to be whatever we want. So that's the second thing I wanted to do to clean this up. Now, the final thing I want to clean up is the player class. Because if you look at this, this is kind of ridiculous. This is a lot of code, and, yeah, it's just a lot of different tasks being managed by one class. And really, I wanted to just have everything that's exclusive to the player in here. And there's a couple of things I'm doing in here that might be used by other classes potentially. So I'm going to change this around a little bit. I'm going to just right-click on my game object package and create a new class. I'm going to call it Stats, because I'm just going to take this whole statistic system and move it out of the player class, because I can think that I'm probably going to be using the same statistic system for enemies, because, it makes sense that an enemy of the same level as a player would have pretty much the same power as a player, so I'm going to move this statistic system out of the player class. I'm going to change it so that the enemy has, the player has a private stats called stats. And that way, it's a lot nicer. So now, we just have to decide what we want to move over. First off, I'm going to move over experience, because everything in our stats system is based on experience. So, I'm just going to move this over, and in my constructor for stats, I'm going to create public stats. It's going to take in float xp, and this will just say xp is equal to xp, and of course I need to change this to this .xp. So there. And that's the basis of our stats system. But of course, this will need to be a little bit changed around, because now all of our stat calculations are pretty much in our player, so we need to move all that over. So first off, I'm going to create, in fact, I'm pretty much just going to copy all of this code right here, and move it over to the stats class. And the reason I'm copying rather than cutting is because, well, I don't necessarily want all these methods to be exclusive to the stats class, because I'm still going to need ways to get max health out of the player class, but, I don't need them all in the stat. Bleh. I'm still going to need methods to get them out, but I don't need all the calculations to be in the player class. So I'm going to move all the calculations over into the stats class, and the player class can just call a basic method. Pretty much a wrapper method. So, there's a couple of things I can clean up in here. First off, I don't need a method to get current health in stats class, so I'm going to delete that. I need the leveling constant moved over, so I'm going to just cut this and move it over. And there, we now have the leveling constant moved over into the stats class. And now, in getSpeed, I can just return stats.getSpeed. So, that resolves that error, or not really an error, but for level, I can just return stats.getLevel. And another cool thing about doing it this way is if I want to later change the underlying system of statistics for the player or the enemy, I can just all change it in this one centralized class, and it'll automatically be changed for everywhere else. So for get max health, I just return stats.getMaxHealth. And I did move get current health, but I actually think I'm going to move it back over to the stats class, because I think it's safe to say that everything in our stats system will also have health. So I'm going to move my stats system over to here. So I'm going to move my health over here. Dang it. I'm going to take a quick break after I finish this cleaning up system, because I'm a little bit tired, as you can probably tell. So, and I don't think it's fair that you get a tutorial where I'm just being stupidly tired. So, and here, I'm not going to import anything because I don't need it. Stats. Oh, I do not need the move method. So I'm going to delete that, and let's see, what else? Okay. Health. I'm going to just initialize health to get max health, because that way everything always starts at maximum health. So Now, after I get max health is working, return stats level, get current health, return stats dot get current health, strength, I return stats dot get strength, and magic, I will return stats dot get magic. And add XP, I'll just do stats dot add XP amount. And there, now we have this pretty much just a collection of getters for all the statistics. Jeez, I'm tired. Okay. So we have this nice collection of just getters for statistics rather than having to do all the calculations in the player class. And it's just a much cleaner way of doing it rather than having this huge list of calculations here. Now we have all the calculations done in the stats class, and it's just, it's just a lot cleaner to do it that way. So, unless I find something else after I take my break, which I will do a check, but unless I find something else, I think that's all the cleaning up we have to do. So thank you, and I'll see you after I take a quick break. Alright everyone, I'm back. I'm still a little bit dizzy, but I think I'm a lot better than I was when I was recording the last part, so hopefully this turns out a little bit easier to understand and just a little bit better in general than the last part. So, now, I did go through the code again. I still can't find anything else I want to clean up, so I did consider just replacing all of these methods with just get stats, but I think that would be a little bit too extreme, so I'm just going to leave it. So, with that all done, let's start adding inventory. So, in the last video, like I said, we added the item system, but we don't have any way of adding it to an inventory. So what we're going to do is we're going to create an inventory for our player, and we're going to set it up so that this method does more than just print something out. So, actually first off, let's just run it and make sure that our changes don't cause a crash. So hit run, and I click try, and so, good thing I tested that, because we have crash. Null pointer I never initialized stats. So, in our constructor for the player, I do stats equals new stats. Okay, that's not, with no experience. Okay, so now we should be now we should be working. So right now I pick up the item, you picked up the cube, it works, everything's happy and good, and, so good. 1 second, I have the hiccups, I'll be back again. Okay, let's hope nothing else goes wrong. And we're back. So, now we're going to set up the inventory. I'm just going to do this in the game class until we have a better place to put it. So I'm going to create a new Java class called inventory. Actually, no, I'm not going to put it in the game class. I'm going to put it in the game object class because it's only dealt with by game objects. So, I'm just going to create in the game object class inventory and click finish. And there, now we have an inventory class. And the reason I'm doing it in a class rather than just the player is because I think that there might be other things that might have some inventory, like maybe an enemy has an inventory, and when it dies, we can collect the items of its inventory. Just speculation here, and if we don't need it, we can always just copy the code from the inventory and move it into the player. But I think it's fair to say that we do need it in a different class in some different point. I think it's fair to say that we will need an inventory for things other than the player in a couple of different places. So, what does an inventory need? First off, we need some items in the inventory. Makes a lot of sense, because, so you need items in the inventory. What items? Well, I'm just going to create a private item array, just called items. These will be all the items in the inventory. And why is it giving me an error? Control-Shift-I, and there. Okay, so we have a list of all the items the inventory has. And the reason I'm doing it with an array rather than an array list is because some places in our inventory might be empty, and an array list does not give us that option. And also, our inventory will always be a fixed size, so we don't need to change that. So that's why it's an array rather than an array list. And At least for the time being, that's all I think our inventory needs in terms of data. So let's just go ahead and start implementing. So first off, we'll just need a public inventory constructor, and here we'll just initialize items. So it'll be a new item array, and it will need a size. So the way I'm going to do this is I'm just going to take in a size for the inventory, and it'll be an array of whatever the size they pass in is. So there, we now have our constructor done. So now we have to start thinking of what methods does our inventory need. So obviously, one of the first things you want to do is you want to add a way to add items to the inventory. So public void add, and it will take in an item. And what this method should do is it should just find the first empty slot in our inventory, and it should add it to the inventory. So I'm going to do this sort of the slow way first, and then later on we're going to go back and make this run a little bit faster. So I'm just going to do for int I is equal to 0, I is less than items dot length. So we're just going to iterate through, it's an I++, and if the item sub I is null, which means there's nothing there, then item sub I is equal to whatever item we pass in. And then, of course, after that, we'll just break out of the for loop. So, definitely not the best way of doing it, but we're going to go back and we're going to go back and make it better later. Right now, I'm just trying to get something that works. And after we get something that's working, then we can go back and add all the fancy algorithms that are super fast and stuff. So, now we need public void get. And right now I'm just going to do get by index, so int index, and that'll just return items sub index. So that's that done, and why is this giving me an error? Oh, public, not void, public item, okay. And I also want to add a way to get an item based on some item. See if the player has some item. I don't know if I'm ever going to use it, but I think it's reasonable to... Actually, I really can't think of any time I'm going to use it, so I'm just not going to implement it just yet. So we have a way to add items, and we have a way to get in items out of the inventory. So, really, I think that should be everything we need, at least for the time being. So, for the time being, this should be everything we need for the inventory. Now, we're going to add an inventory to our player. So just a private inventory. And here we're going to set inventory to a new inventory. And there, now we have an inventory for our player. Why is this giving me an... Oh, Control-Shift-I. No? Oh, because I didn't pass in the size. Oh, I'll just have the player start with an inventory of 20 items. And we'll see where we go from there. So, actually, now that I think about it, there's one more thing I want to do. And... actually, I'm going to change the add method to a boolean. I'm going to have it, if it adds the item, it's going to return true. If it does not add the item, it will return false. So, there, now in the add item method, we'll just do inventory.add item. So, there, now it should, in theory, have, it should have our item in our inventory. And just to test this, I'm going to go to the add method. I'm just going to do system.out.println. It'll say item, in quotes, item plus item.getName. Is there no getName method for item? Oh, okay. I guess I didn't add it, so we'll add a method to get the name. So in our item class, I'll just create a public string getName, and it will just return name. Simple enough. item.getName. Okay, so we'll say item, then the item name, and then what we're going to do is just add on to that. We're going to say that that item has been added to inventory at index plus whatever index we added it at. And that should be the very basic. It should work. Let's just say that. I'm sorry I'm so tired in this video. I hope I'm not as bad in the next video. So we're just going to go over the item, and it says item the cube added to inventory at index 0. Okay, great. Our inventory system is working. So I thought of another method that I'm probably going to want at some point, and that is just a way to remove items. So I'm just going to do public void remove. It'll either take in an index, and it'll just set item subindex equal to null. And I'll also have a remove method that takes in an item, and that will just set, I delete that, that will set, okay, why is that giving, oh, 2 equals, no. Okay, remove one of those equals, that should only need to be 1 equals. And this one will work by doing the same sort of not as good way of doing it that we're using there. So for int I equals 0, item I is less than items.length, I plus plus. And here what we're going to do is we're going to set items if item sub I is equal to whatever item we pass in, then we're going to set item sub I to null. And that way we'll just get rid of whatever item is in our inventory, essentially. And yeah, okay, I'm sorry. That should be everything we need. So, just to quickly test that out, I'm going to add a message here, which will say item. Actually, I should trigger this first at some point. Actually, you know, it's going to work, so I'm not even going to bother testing it, because there's really not that much that can go wrong here. Okay. So the only thing I really want to do here is I want to make a slightly faster add method, because right now it essentially has to search the inventory for the first free spot every single time. And you know, that can get slow, especially in really big inventories. So I'm going to add an integer. It'll be a private int called first free. And this integer will be, it'll keep track of whatever the first place in our inventory that is empty is. So I'm just going to set here first free is equal to 0, because the very first index that will be free is 0. So first off, I'm just going to I'm actually going to comment this out just for temporary purposes. So temporarily going to comment that out and say, first off, I'm going to check if first free is equal to -1, and that will mean there's no free spaces in our inventory. Actually, I'm going to make it test items.length, because that would mean there's no free space in our inventory. So what I'm going to do here is, if we have no free space in our inventory, then we're just going to return false, meaning we didn't add the item. So if we didn't add the item, then we're just going to return false. However, if our first free is a valid index, then we're just going to say items sub whatever our first free index is equal to whatever the item is. And we shouldn't have to test if our first free index is null, because it should always be null. So now after we have added this item to our inventory, that's when things get a little bit weird, because we have to test if, or we shouldn't really have to test, but we have to figure out where the next first free index is. So the way I'm going to do this is I'm just going to do another for loop for the time being. So for int I is equal to 0, and then I is less than items dot length I plus plus if item sub I is equal to null. Actually, I should say a sub first free. It's because we already know that every other index is free. So first, starting at first free plus 1, because we just added something. If item sub I is equal to null, then what we're going to do, simply enough, is if it's null, then that means that's free. So first free is equal to that index, and then we're just going to return true. First free equals I. Okay, there. I'm sorry, I'm getting tired. So that should be everything we have to do here. And really, that should be everything we need to replace this. And one thing I think is interesting to note is it does not reduce the total number of things we theoretically have to do to get to the next index. So it doesn't reduce the maximum running time of the method, but what it does reduce is the average running time of the method. So it will make it, on average, be a little bit quicker than usual. So, now, not all code paths return a value, okay? Actually, I should just do here, I'm just going to do break, and then I'm going to just return true. And then, actually, I need to do return true here. And if it's not, then first free, that means nothing's empty, so first free is equal to items.length. And really, yeah, I'll just do it like this. And it doesn't matter, as long as you have some number that will be an indicator that there's no free space. And in this case, I'm just using the length of the item. So, there. Now, that should... yeah, it should be everything we need to do for the add method. The slightly faster add method. It's not that much faster, but, you know, it's not that hard to do, and it's a little bit faster, so why not? The only other thing we have to do is when we remove something, we're going to have to check, because if we remove something that introduces a space that's probably before the first free index, so we'll have to check for that. So, what I'm going to do is I'm going to here, in the remove method, I'm going to test if index is less than the first free index, then the first free is equal to index. 1 equals. Good lord. Okay, then in our if statement, first off, I'm just going to here, I'm going to return, because this is going to be the end of the method if we have found the item. So if, now here we're going to do the same thing. If I is less than whatever our first free index is, then the first free index will be equal to I. And again, the reason for this is, since we're keeping track of it based on index, if we've just removed something that's before our first free index, then logically that must be before our first free index, so yeah. And I think I'm actually just going to call the video here. I know this is a little bit shorter than most of the things we've done, but I think that my tiredness is just making this a really substandard video by at least my standard, so I'm sorry that I had to put you through this, but I hope you forgive me. I hope I do better next time. At least I hope you manage to get something out of this. And thank you, and see you next time.